Welcome to another lecture of our automata playlist. Today we are going to check some examples of how to design PDS. So if you want to know what is PDA and how to make PDS, I will suggest you to refer to my previous video of our playlist, and there I have described everything about PDA. Today we are just going to see some examples. Suppose there is a language 0 to the power n, 1 to the power 2n. So what does this mean? This means there must be twice the number of ones inside our language as the number of zeros. Okay, so if there is 1 0, there will be 2 ones, and there is no mixture of placings because all the ones will be after the zeros. So first we have a state q0, and from here we are receiving null from our input, and we are replacing the null in our stack top with z0. This means we are just pushing z0, that is our stack symbol, inside our stack. So now our stack only have z0, and I have taken an example here. So of this type of language, so this is like 2 zeros, and corresponding to 2 zeros we have 4 ones. So now we have reached in state q1. So what we are doing now, we will just push the zeros. Okay, so this means whatever, how many zeros we are receiving, we will push them inside our stack. So for the first 0, we will replace the stack top's null value with 0. This means we are just pushing 1 0. So here we have 2 zeros, so this means there will be 2 zeros inside our stack. So there should be the equal number of zeros inside our stack as the number of zeros in our input string. So now when all the zeros are pushed, now what we will receive? We will receive 1. So when we receive 1 and our stack top has 0, so then we are doing nothing, we are just leaving it as it is. This means we are replacing this 0 with again a 0, so it will remain similar. Now we reach a new state, that is q2. Now from q2 we are again receiving 1, and now we have 0 in our stack top. So now we will pop this 0. This means for a single one we are doing nothing, but for every pair of ones. Okay, so if we have 2 ones, then we are popping 1 0. So that's how we will maintain this equality condition, that is for every 0 there should be 2 ones. Okay, so for every 2 ones we will pop 1 0 from our stack. So for the first one we are doing nothing, we are leaving the 0 as it is, and for the second one we are just removing our 0, that is we are popping our 0 from the stack. So now this 0 is popped from our stack, and now our stack only have 1 0. So now, and it reaches a new state, that is q3. So after reaching q3, it will again have 1 here. So for again it is the first one of the pair, so it will do nothing, it will just replace the 0 with 0. So then our stack will remain similar. Okay, and after that it will go back to our previous state, that is q2, and again for this q2 it will have 1 from our input string, that is now our pair is completed. So it will do what? It will again remove our 0 from the stack. So now this stack 0 will also be removed and replaced with null. So this loop will do what? This loop, particularly q2 to q3 and q3 to q2, this loop is doing what? This loop is ensuring that for every pair of ones we are popping 1 0 from our loop. Sorry, from our stack we are popping 1 0 from our stack. Okay, so we are pushing 1 0 for every single 0 we are having, and we are popping 1 0 for every pair of ones we are having. So this means the number of ones will always be twice the number of zeros, and after that when we have only the stack symbol left, then we are just going to our final state and popping the stack symbol. So now let's check another similar example for PDA. So see, here it is saying that we have a language w or a string w which has 0 and 1 in it. Okay, so this is a combination of 0 and 1, and how this combination works, where number of zeros inside w is equal to number of ones inside w. So how do we do that? So let's first check. So first we have q0. Okay, so the number of zeros must be equal to number of ones. So suppose we have an example 0 1 1 0 1 0. Okay, so suppose this is our example. Now see, so first whenever we are having whichever letter we are having first, we are pushing it inside our stack, and whenever we are having the different letter inside our input symbol according than the letter which is already present inside our stack, then we are popping it. So if our input stack and our stack stop is matching, then we are pushing it, but if they are different different alphabets there inside our stack top and inside our input string, then we are popping it. So let's see. So if first we have 0 and there is a different style we are using here. So here I was just using one symbol here. Okay, now we are doing what? We are popping Z0 and we will push Z0 and 0 together. Okay, so I will just write two symbols inside here. So let's see. When we have 0 inside our string, we are and Z0 inside our stack top, we are popping Z0 and pushing 0 Z0. Okay, so we are pushing 0 Z0. So now our input string has 0. And if we had 1 in the first place, then we would have done the same, but we would have pushed 1. Okay, so whatever symbol we are having inside our string, we are pushing it into our stack. So now and we are remaining in the same state. So for 1 also this will be the same, but now our stack top has 0, but our input string has 1. So what we will do? So for our input string having 1 and our stack top having 0, we are popping this 0. So now this 0 is popped. Okay, so now this means that number of zeros and number of ones are similar. So now again we are having what? We are again having 1 and our stack top is null. So when we have 1 and our stack top is null, that is Z0, we are doing what? We are pushing 1 inside it. So now our stack top will become 1, and again our stack top becomes 1 and our input symbol has 0. So what we will do? If our stack top is 1 but our input symbol is 0, we are again popping it this 1. So we will just remove it. So see, whenever our stack top and input symbol is different, we are just popping it. But if these are similar, or if this is our first element, then we are pushing it. Okay, so we have again 1, so we will push 1, and now what we have? We have 0, so we will again pop it. But for 0 we will pop it, and again for this 0 we will push 0, and again for this 0 we will pop 1. Okay, so this is how it is done. So now let's check for another symbol. Suppose we have 1 1 0 0. So now let's check the stack for it. First it has Z0. Okay, and first what will happen? First 1 will be pushed here. Now what it has? Now our stack top is 1 and our input symbol is also having 1. So now what it will do? Now let's see. For our stack top 1, input symbol also 1. Then it will push again another 1. Now our stack top is 1 and input symbol is 0. So now it will pop 1 by 1. Okay, so now this will be accepted, and after this doing every loop inside this single state, we will just reach our final state for the Z0 and null. Okay, so if there was also the another string, suppose it was 0011, then what it would happen? First the 0 would have been inserted into our stack, and then for again this for second 0, this rule will be applied, that if our input string is 0 and also our stack top is 0, then the same 0 will be pushed, and after that for these ones this will be popped out. So the basic rule for this will be similar, that if the input stack and the stack top is same alphabet, okay, if our input symbol or input alphabet and the alphabet present in our stack top is same, then we will push it. But if these two are different, then we will pop it. Okay, and if there is nothing present inside our stack, then we will also push it. So that's the basic rule, and this all things complex production rules just means the same thing, that if these are same, so see, if these are stack is already empty, then we are pushing it. If the stack symbol and the input symbol is different, then we are popping it, and if the stack symbol and input symbol is same, then we are again pushing it. So that's the basic rule of this thing. So hope you understand it. So do subscribe if you understand it and share with your friends.